What's up? This is the LeetCode Week 4 challenge, and I'm gonna solve one of those challenge. So this is the linkless cycle 2. 2? What's with 2? Okay. So in this problem, we have to find if a cycle exists in a linked list. Okay. So we are provided with a head pointer, which is pointing to the first node of the linked list, obviously, and we are provided with a head pointer. That's it. And in the linked list itself, it's internally written at what position there's a cycle starts. Okay, so for starters, we are given a linked list with a head pointer pointing to the first node of the linked list, and there exists a cycle. There may be existing a cycle. We don't know. So our task is to find the cycle. Like if there exists any cycle, we have to say that yeah, there's a cycle. The tail connects to that particular node, and yeah, that's it. So in a linked list cycle one problem, we had to find if a cycle exists or not. But in this problem, we have to find from which position the cycle starts. Like I'm gonna show you an example. Like in this first question, the tails points to the second node in the linked list. So basically, we have to answer that. We have to join this two nodes. Okay, so we will perform this thing by two pointer method where we'll take two pointers, namely slow and fast. Where's the pen? Pen, yeah, here. This is the head node. Now there's a slow pointer S and there's a fast pointer F. Both are pointing to the very first node of the linked list. Now the properties will be slow pointer will move or iterate by one index, my pen, S of index of next, and the fast pointer F will iterate by two nodes. That is, it will jump through two nodes. F of, again my pen, I'm sorry. Yeah, so it will jump by two nodes. F next, that's N, sorry due to lack of space. Yeah, so the properties are the S slow pointer will move by one node and the fast pointer will move by two nodes. Okay, so solve the problem. So initially, both the pointers, slow as well as fast, both are pointing to the first node. Now for the first iteration, what will happen? So for the first uh, for the first iteration, the slope pointer will move by first node, and the fast pointer will move by two nodes. Again, we will iterate, and the slow will move by one. But this time, the fast will have to move by two. But fast cannot move by two because there is no node present at the next of tail. But if you see, the tail is connected to the second end node of the linked list. It was given in the question. Now we will again iterate S by 1 and F by 2. So you see both the pointers S and F are pointing to the same node. That means there is a cycle in the linked list. So this proves that there is a cycle in the linked list if fast pointer and slow pointer point towards the same node, or they both meet at the same node. Now what we are going to do, our second task or next task is to find if there from what position the cycle starts, of at what position the tail is pointing to. Let me just clear it. Just let me clear the screen. Okay, so fast, we will keep fast where it was last kept at, but we will again reallocate slow to the towards the head. So slow is pointing towards head and fast is pointing towards tail. Now we'll iterate S1 and F is also iterated by 1 only. This time in the second iteration, we will move fast by one node only and slow will obviously move. Okay, so you see both slow and fast, they are again pointing to the same node. So what this thing signifies? This thing signifies that the tail is pointing to the second node of the linked list. So this actually solves our problem. That was the very basic approach how you're going to solve this problem. This says that the tail is pointing or it is connected to the node present at second index. So this approach was pretty much easy. And yeah, obviously you can say that our cycle starts or begins. Anyway, so I'm gonna code here. So as I said, we will take two nodes, sorry, two pointers. Slow, fast, both will begin by pointing towards head. Okay. So as I told you earlier, we will do it two type iterations. In the first iteration, we will just move slow by one note and fast by two notes. And in the second iteration, we will move slow and fast both by one note. So what would be the condition? So we will do till fast or fast next is not null. That is, the note pointed by fast is not the last one, or the note pointed by fast next is not the last one. So let me write it out. Write it down. Slow next. No. Sorry. My bad. My bad. It should be fast and equal to null. And fast next is not equal to null. So this is our first iteration. Now, as I told you earlier, slow equals to slow next, and fast equals to fast next, next, because we will move here by two notes. And if at any point the slow and fast point to the same note, what we will do? Then we will reallocate slow to head, and we will again iterate the whole linked list with the slow moving by one note and fast moving by one note. And we will do that till again slow and fast move at some point, meet at some point. So slow equals to next and fast equal to fast next. We will just move by one note. So I think that's it. Okay, so we have to return here. Okay, let's return slow, because slow fast doesn't matter. They both will point towards the same node at the end. And if nothing is found, then return null. Let's see. Run code. Okay, it works. Now let's submit. It should pass all the test cases. Yeah, it did pass. Okay, that's it.